Hi everyone, this is Mrs. Crawford. This is Unit 1.3, Day 3 on reflections. Now, previously we've talked about translations and how to tell how much or what distance you should slide it across the graph. Today we're going to talk about reflections and how you do that in a graph as well. It's going to be quite a bit different. It's not going to use the same kind of coding like we did before. You're not going to have to know left, right, up, or down. It's going to be a little bit more visual than that. Now I'm going to give you two ways that you can do this on a graph, and I'm going to strongly suggest one of them because the other one, A, is usually a little bit more difficult to figure out, and B, isn't actually able to be used all the time. But I do want to show you so that you're aware of it and that you can use it if that works for you. So here's the first type. This is the more difficult one. So hear me out with it. If you don't understand it, that's fine. Just wait until I do the next one. But I did want to talk through this one. What this way is kind of like what we were doing with translations. And you'll even notice that the notation kind of looks the same, right? Before we had x plus something or minus, and same thing with y. But with reflections, you're not actually moving it, you're just flipping it, which means the numbers aren't going to change, just their signs might change, which is why you see all these negatives kind of tucked in here. So you can only do this technique if you're going to reflect over the x-axis or over the y-axis. So in other words, you can't do it if it's any of those other lines outside those axes. So that's why it's not really my favorite way of doing reflections, but I do want to show you. So let's take a point, for example. So let's say this point on this shape, let's call this the original one. Oops, no, JK. Let's call this the original one. We'll say this is A, and let's say this wasn't here, and I wanted to figure out A prime. We'll say that this is 2, 1. I'm just making it up, okay? I just came up with a random number that looked like it could be that spot. What this rule says is that if I start out at 2, 1, which is x, y, it's going to reflect, and the x will stay the same, and the y is going to have the opposite sign. That's what that negative in front means. It doesn't mean negative all the time, every time. It just means opposite sign. So in other words, if my original x value was 2, it's still going to be 2. If my original x value was 1 though, or sorry, my original y value is 1, it's going to flip and become -1. So that means that this a prime down here, if this is 2, 1, this must then be 2, -1, and then you can use that to find the other points. Okay, so that's what that means. That's what that notation is referring to. Same thing here. Let's say that B was 5, 1, just making up a point again. Okay, if it was originally 5, 1, this rule says x stays the same, y gets the opposite sign. So 5 stays the same, 1 gets the opposite sign. So that means B prime, forgot to put the prime symbol over there, is 5, -1. Okay. Similarly, if I'm reflecting over the x-axis, the rule is then flipped. Instead of the y value changing, it's the x value changing. So let's say that this was A, and it was 2, 2. Or let's say 3, 2. Just to make them different numbers. 3, 2. I know it doesn't look like that. I don't care. I'm just making random numbers. With this one, if I'm flipping over the y-axis, this tells me that the x gets the opposite sign and y stays the same. There's nothing there. So x instead of 3 is going to be -3. 2 is going to stay the same. And I know that it's not in this picture, but let's just say we had one with a negative, like -3, -5. Let's say that that was on our original. Maybe it was B, and this was A, and this is A prime. If I'm going to reflect it over the y-axis, the opposite of -3, remember this means opposite, not just negative. The opposite of -3 is going to become +3. Y is going to stay the same, so it would look like that. Okay, so that's one technique you could use, is just using the coordinate notation that they've shown and using that rule to figure out what symbol you're going to flip. Now, I don't really suggest that way. I think that way only works a few times. So I suggest what I call jump the line. Now, I've got the steps already written out for you, and I'm going to put it into action with one of our next problems. So we'll see if this allows me to do it. I have a feeling it's maybe not going to. We'll test it out and see. So I'm going to keep this here. There we go. I got what I wanted there. Okay, so my page is pinned, so this one on the left is going to stay there as I progress through the next ones. Now, first of all, the line of reflection, your fill in the blank there, is that it's the perpendicular bisector of the segments, and that sounds really confusing. I'll try and get into that a little bit later on, but just make sure you have that written down. I'll kind of tie that in a second. All right, so I'm going to move on to this one. So my first step when I do jump the line is I want to draw in the line of reflection. Well, this one's being reflected over the y-axis, so that means I'm going to really bold in the y-axis, just like this. So follow me on your paper. Hopefully your drawing is a little bit less scratchy than mine is. And let's see if it'll allow me to zoom in. Nope. That's okay. We'll figure it out without it. We can still see it. All right, so next I'm going to pick a point and count how many units away it is from the line of reflection. So let's start with C. If I look at C, how far away is that from the line of reflection? Well, it's 1 unit away. Step 3 says jump the line and count the same number of units to the other side. So if I'm on my line, this is 1 unit away, this is 1 unit away. So you can even draw some little jumpy things like that. Okay. Plot the new point and give it the prime symbol. So this is my new C prime. It's really hard to draw the prime symbol there. That should say C prime. And then repeat for all other points. So if I'm going to do it with D, D is 1, 2 steps away. 1, 2 steps away is now D prime. Same thing with E. E, I'm going to just look at it this time as 1, 2, 3, 4, 5 steps away. So I'm going to go 1, 2, 3, 4, 5 steps away on the other side, which makes sense because it's being reflected. It should be the same on both sides. Think about if you took a piece of paper and you folded it right down this line. I should be getting the same mirror image on both sides. And then F is 1, 2, 3, 4. 1, 2, 3, 4. There's F prime. That was a bad dot. And then our picture gets connected. And it should look like the mirror image of the original, which it does. It's kind of rough, but you can still tell it's reflected across. It's a mirror. Okay, so I'll do another example to kind of show you. So same thing here. This time we're reflecting over the y-axis. And actually I'd like you to pause here real quick and see if you can do it yourself correctly. Press play when you're ready to see the answer. Okay. So start by drawing in the line of reflection. This time it's the x-axis. Please pay attention to those directions. So this time I'm going to put that right there. Okay, and one at a time I'm going to see how far away the points are and then jump across the line to get the new point. Well, if I look at S, that's right on the line itself, which means it's 0 units away, which means it's going to stay there for the new picture. So I don't have to move S at all, which is kind of nice. Let's go to R. R is 1 unit away here, so it's 1 unit away over here. There's R prime. T is 3 units away, which means over here it's got to be 3 units away. It's reflected across the line. So there's T prime. So if I connect them, and imagine if I folded this paper across that red line, should get that same picture over there. And if you're not sure what my points are, you should be able to do this on your own. You should be counting the steps yourself, not just trying to copy my picture same as what I've got, because it's a little messy. All right. So now these guys, this is where it gets a little bit tricky. We're no longer using the X or Y axis. So it's going to be a little bit different this time. So I'm going to go out of my dual view now that we've kind of got the hang of those steps. So we get a little bigger. Now this is kind of a special line. Now you got to be able to read what that means. Reflect over y equals 2. This is a line. Okay, it's a line because it says y equals. It's a line that cuts through the y-axis. If it said x, it'd be the x-axis, but it says y equals, so it cuts through the y-axis at 2. That's what that means. So on your graph, find the y-axis. Where is positive 2 on the y-axis? It's right here. And I need a line that cuts through at that spot, which means it's going to look like this. I can't draw it this way because then that's the y-axis itself. So this blue line is now my line of reflection. Then I just proceed like normal. Count my steps. C is already on the line, so that's going to be C prime. E is 1 unit away, so jump across. I get E prime. D is 3 units away, so I'm going to jump across and go 3 units down. And then there's my D prime. Poorly drawn, but there's my triangle, and it's reflected across that blue line. So it doesn't always have to be the x or the y axis, okay? It's not always going to look like that. Go on. All right, I want you guys to try this one out. When you're ready, press play, and I'm going to run through it very quickly because I'm starting to run out of time, but you should be trying this yourself to see if you can do it. Remember, this means line that cuts through x-axis at -3. So find the x-axis, find -3 on the x-axis, draw a line through it. There's your line of reflection. I prime, F prime. Again, I'm counting my units. H is on the line, so it's going to stay in the same spot. And G is 1 unit away, so it's G prime. So there's H, I, F, G. And it's reflected across. All right, down here now, we're going to be doing it with just points. And then you're doing it based on that line. And I think it's, whoops, I'm sorry. I believe it's all on one picture for you guys. Go ahead and try that on your own. See if you can fill in all of those numbers and then press play when you're ready and I'll run through that. Okay, so A is at 2, 4. What are the coordinates of A prime if A is reflected over the line y equals 1? Well, y-axis is here. 1 on the y-axis is here, so here's my line of reflection. That dot is 3 units away. Jump 3 units over. There's A prime. And it is at -2, -2. Because remember, this is not my origin. This red line is just my line of reflection. So this is still the origin. So it's still 2, -2. That's A prime. Okay. B is at the point -1, 3. There's B. I'm reflecting over x equals 3. So on the x-axis, find 3. Draw a line through it. And flip that point. So 1, 2, 3, 4. 1, 2, 3, 4. There's B prime. And if I count my units, 1, 2, 3, 4, 5, 6, 7, 3. Okay, so I'm going to skip these next ones. So I want to talk about the rule. So here, oops, sorry guys. Here's how you figure out the rule here. You pick 2 points that are the same letters. So I'm going to pick B and B prime. And then you connect your dots. Figure out how far apart they are. They're 6 units away. Line of reflection has to be right in the middle of the 2 shapes, which means it's 3 units in on each side, so it's right here. So this is reflected over the x-axis. So I would say that to describe the rule. Homework's on the bottom.